Hello everyone. My name is Pompey and I'm from SSC Bangalore. So today we are going to learn about Finder's algorithm. So this is the introduction to the Finder's algorithm. So what is this Finder's algorithm is? So it's a machine learning algorithm used for finding maximal specific hypothesis in a hypothesis space given a set of positive examples. So it is basically a rule based algorithm that can be used for classification tasks. So the goal of this algorithm is to learn a hypothesis that can correctly classify new instances based on their attributes. So this algorithm works by initializing the hypothesis to the most specific hypothesis in the hypothesis space and then refining it based on the positive instance in the dataset. It is a simple and efficient algorithm that is widely used in machine learning and artificial intelligence applications. So coming to the working, so the Finder's algorithm starts with the most specific hypothesis possible, which assumes that no attribute has any value. It then iterates through each positive example in the training data and updates the hypothesis by generalizing it to include the attribute of the example. This process continues until all positive examples have been covered. So this is the algorithm. So in this algorithm, H represents the hypothesis space, which consists of all possible hypotheses that can be learned by the algorithm. The hypothesis H is the initialized to the most specific hypothesis in the H, which means that it assumes that all attributes of positive instance are relevant and present in the target concept. So for each positive training instance X, the algorithm checks the attribute A in X and compares it with corresponding attribute in H. So if the values are not in the same then H, then made more general by setting the value of A to question mark, which means that the attribute A is not relevant to the target concept. So after processing all positive instance, the final hypothesis H is returned, which represents the most specific hypothesis that fits all positive instances in the training data set. So next we have this example. So in this example, we have a data set of different fruits and their characteristics, including their color, size, shape, and taste. So the goal is to learn a hypothesis that can correctly classify a new fruit as their sweet or sour based on its attributes. So to do this, we use the Finder's algorithm, so which works by initializing the hypothesis and to the most specific hypothesis in the hypothesis space and then updating it based on positive instance in the dataset. So in the second step, we process each positive instance in the dataset and in the and update the hypothesis by setting the values to the hypothesis more general. So in the third step, after processing all positive instance, the final hypothesis is the most specific hypothesis that fits all positive instance in the data set. So in this example, the final hypothesis is yellow, large, curvy, and question mark, which correctly classifies all positive instance in the dataset and can be used to predict whether a new fruit is sweet or sour based on its attribute by showing the table and explaining the steps of the finder's algorithm. So this is the Python code, and in the first line we have the function called the finder's algorithm that takes a list of training examples as input. So these are the examples, and in the second line, the line initializes the hypothesis of the attribute values of the first positive example in the dataset, and this -1 is used to exclude the class label. And coming to this part of code, this block of code iterates over each example in dataset and checks if example is positive. And then we iterate over each attribute value in the hypothesis and compare it to the corresponding attribute value in the example. If the attribute value in the example is different from the attribute value in the hypothesis, we set the attribute value in the hypothesis to the question mark. So finally, the function returns the hypothesis, which can be used to classify new instances. Coming to the limitations of Finder's algorithm, one of the major limitations of the Finder's algorithm is that it only considers positive and negative examples and does not take into account any prior knowledge or background information. Other limitation is that it can only handle categorical data and cannot be used for continuous data like numerical values. So later we have the applications of Finder's algorithm. So this Finder's algorithm is commonly used in the field of artificial intelligence for tasks such as classification and pattern recognition, and it also been used in various other fields such as bioinformatics, NLP, natural language processing, and robotics. So finally, coming to the advantages of Finder's algorithm, one of the major advantages of Finder's algorithm is that it is simple and easy to understand. So it is also computationally efficient and can handle large amount of data without requiring significant computational resources. So the conclusion is the Finder's algorithm is powerful machine learning algorithm that can be used for a wide range of applications. While it has its limitations, its simplicity and efficiency makes it more popular choice for these researchers and practitioners in the field of artificial intelligence.